Good evening. I'm Spot On Weather meteorologist Matthew Euler, and tonight we're going to talk about something very appropriate for this time of year. We're going to take a look at tropical weather, and this is a lesson on tropical weather. We are in the hurricane season right now. It runs from June 1st to November 30th, so let's jump right in. There's a lot of material to cover, and I really hope everyone finds this interesting. All right, so first we're going to start off with the requirements for tropical cyclone formation. The first thing we need is a warm sea surface temperature greater than 79 degrees Fahrenheit. These warmer sea surface temperatures act to add moisture and heat into the tropical system as it develops. Next, we need minimal vertical wind shear to allow thunderstorm tops to keep growing taller and more vertically. For wind shear, really what that is just imagine that you have wind speeds blowing or wind directions as you go higher up in the atmosphere coming from different directions. So different wind directions, stronger wind speeds as growing thunderstorm tops try to basically move up in the atmosphere. What happens is with greater wind shear, it rips those thunderstorm tops apart. We also need formation at least 5 degrees latitude away from the equator in order to create a spin. And this is associated with what's known as a Coriolis force, which is an apparent force in the northern hemisphere. It's an apparent force as the wind blows over the surface. There will be a twisting motion due to the Earth rotating beneath this air current. Next, you need a surface low pressure area. Some systems in the tropics, they typically exist at the upper levels in the form of upper level lows. And a lot of times, in order for a tropical system to develop, the circulation must work its way downward to the surface before further development can occur. So that's very important to have that surface disturbance or that surface low pressure area, a cluster of thunderstorms developing around that center of that surface low pressure area. And then we also look for no dry air entrainment. And a lot of times what will happen is you'll get drier air, especially more towards the eastern Atlantic Ocean as these tropical waves come off the coast of Africa. What you have happen is you get this dry desert air from the Saharan desert that gets basically blown into a developing tropical system. And what that tends to do is it tends to suffocate or cut off the moisture and will eventually dissipate the clouds. Whenever you bring dry air in, that's going to dissipate the clouds. All right, so let's take a look geographically across the world. Where do tropical cyclones typically form? All right, so if we look in the Atlantic Basin here, we have a favorable area. Again, remember it's got to be 5 degrees latitude north or south of the equator because basically there's zero Coriolis force or zero turning or twisting motion along the equator itself. So notice over the Western Atlantic, into the Caribbean, Gulf of Mexico, and then even off the east coast of the United States are favorable formation areas. And then in the Eastern Pacific, you can go from basically off the coast of Mexico, mainly spreading west across the Hawaiian Islands. And yes, Hawaiian Islands have been hit by tropical systems before, by the way. In the Indian Ocean and the North Arabian Sea, and then also further south of the equator in the southern hemisphere, and then also in the western Pacific Ocean, hurricanes come by a different name known as typhoons, and that is just in the western Pacific there. So these are the favorable areas across the world for hurricanes, tropical cyclones in the Indian Ocean, and then also typhoons in the western Pacific. All right, so trade winds will typically converge along what's known as the Intertropical Convergence Zone, and this forms hurricanes. So what you have here is we have a picture of northeast trade winds and then southeast trade winds. And this pink area here, this represents Intertropical Convergence Zone. So anytime winds meet, winds blow from the northeast in the easterly trade wind belt, and they blow from the southeast in the southern hemisphere easterly trade wind belt. Whenever these two winds meet up, air must rise. And that's what creates what's known as Intertropical Convergence Zone. If you look at the chart here, this blue line shows you the average position of the Intertropical Convergence Zone. Typically what it does is it follows the path of the sun. So when we're in the northern hemisphere summer, the intertropical convergence zone is at its northernmost latitude. Okay, and then look at the dash line. Look how much further south the intertropical convergence zone goes into the southern hemisphere in January. Much further south than July timeframe. So let's look at the tropical cyclone classifications, just the definitions briefly. A tropical depression is a tropical system with sustained wind speeds basically at less than 39 miles per hour. A tropical storm is basically a tropical system with sustained wind speeds now between 39 and 73 miles per hour. And at this stage, a name is assigned to the storm when we reach tropical storm classification. And then a hurricane is a tropical system with sustained wind speeds of 74 miles per hour or greater. The hurricane intensity scale will range from a Category 1 to a Category 5 hurricane. And we'll get into that more into that later. So we start off as a depression, which is just a cluster of thunderstorms with these wind criteria. And then we go to, as this depression continues to strengthen, if conditions are favorable, based on what we talked about, minimal vertical wind shear, 79 degree or greater water temperature, no dry air getting entrained or sucked into the system, it becomes a tropical storm. And if it strengthens further, it becomes a hurricane. All right, so let's take a look at hurricane, and it's known as the ultimate heat engine for a reason. Okay, it's a warm core where the warmest temperatures, it's a warm core low pressure system where the warmest heat, the greatest temperatures are in the center of it. And what it does is it really basically its survival depends on that warm ocean surface to continue to feed it that warmth and moisture from the surface. All right, so air is going to rise, and these are your particular rain band areas here where the air is rising outward away from the center of the hurricane, which is known as the eye. You typically have weak winds aloft over the top of this, typically high pressure systems, very light winds, which allows for great outflow, or as this air rises, it's got to go somewhere. It evacuates out the top of the hurricane. All right, and typically you'll get these outflow, basically they're called cirrus clouds over the top of the system. All right, and then the eye wall is immediately the major rain bands just immediately adjacent to the eye itself. And the eye is an area where the air is actually sinking. High pressure aloft or above the hurricane results in sinking air down through the center of the eye. So let's look at the key parts of a hurricane. The eye is the region at the center of a hurricane where the sky is relatively clear with the lightest winds. The barometric pressure is the lowest in this area of the storm. And many people in the past have mistakenly thought a hurricane was over when the eye passes over their location, and they go outside and start assessing all the damage just for the winds to pick up from the other direction to high destructive levels again. The eye wall itself is the most dangerous portion of the hurricane where the strongest winds and heaviest rain occurs. And then rain bands typically will propagate or move outward away, extend outward away from the center of the eye. And these are bands of heavier rain showers and gusty winds. These typically the typical weather you have with rain bands is heavy rain showers, gusty winds, and the precipitation, the rain, it starts and stops relatively quickly. So there again is the overall structure, and there are the definitions of a hurricane, the key parts. So tropical cyclone threats, what are the big threats with hurricanes? Okay, well, we definitely have destructive winds. Some of the strongest winds on Earth occur in hurricanes, period. Storm surge, this is the deadliest aspect of a storm, especially when combined with high tidal cycles. So storm surge, what happens is the center of the eye, if we go back, this eye here with all this lower barometric pressure, what happens is, I want you to imagine sucking soda out of a straw. You know, if you have soda in a cup, you have your straw in there, you suck the soda up. Well, as you suck the soda up through the straw, that causes that liquid to rise into the straw, correct? So the same thing happens within the eye. This is the area with the lowest barometric pressure. That results almost like a vacuum effect and will suck the ocean level or the sea level higher into it. And that results in a building area of higher seas. And as this system comes onto shore, makes landfall, that huge wall of water, the storm surge, comes in and inundates low-lying areas along the coast. So storm surge is very deadly. This was especially a deadly aspect of Hurricane Katrina. along the Mississippi Gulf Coast in 2005. Flooding rain's another big threat. And you know what? It doesn't take a hurricane. Even tropical storms can result in some of the most catastrophic flooding events of the past. Tornadoes form in the northeast quadrant of a hurricane when the wind shear increases to very high levels. So what happens is, as a hurricane makes landfall, the upper level winds continue to blow very strong above the surface. They're not slowing down. While the winds at the surface of the ground itself, they tend to slow due to friction. As wind blows across the surface, it's slowed as that wind comes in contact with landmass. That results in extremely high wind shear. So basically, you may have winds of 60 miles per hour at the surface, but if you go up to 5,000 feet above the storm, you get winds maybe still at 100 miles per hour. So a 40 mile per hour difference in wind speeds between the surface and 5,000 feet. What will happen is if you get any kind of thunderstorms to develop, as they rise, they start rotating, and that results in tornadoes. And this typically occurs in the strongest quadrant of a hurricane, which, by the way, is the northeast quadrant. All right, and how do we track these hurricanes? Well, the hurricane hunters go out with these special planes. They're equipped with special instruments. This is an example of a NOAA P-3 plane. This is an example of a C-130 plane. It typically flies out of Keesler Air Force Base. So these brave men and women, they go into the center of the storm here. They do sampling missions in and out of different sections of the hurricane from above. They drop instruments known as dropsondes, which measure humidity, temperature, and barometric pressure as they descend on these parachutes here. So that is really interesting. That's how they get the data, and then they send that data to the National Hurricane Center to give them the latest updates. And then you typically see that on the local newscasts, as well as like the Weather Channel, for example, the updated graphics. This is the hurricane intensity scale, just showing you the different categories of hurricanes. And each category, okay, takes into account the storm surge and the sustained winds. Now, when I say sustained winds, I'm talking about winds that constantly blow, not the wind gusts. The wind gusts come and go, but the sustained winds are actually how the wind is blowing across the surface constantly. But you notice category 1, 2, 3, 4, and 5, with category 5 being the strongest, the storm surge 19 plus feet with a category 5, with winds 156 miles per hour or greater. Obviously, that's not very good for any structure that is in the path of a hurricane at this strength. So you see the different storm surge ranges, as well as the wind speeds and how they increase from category 1 to category 5. And then to end this lesson, I wanted to talk to you about the 2017 Atlantic Hurricane Season Outlook. So we have basically a 45% chance. NOAA, the Hurricane Center, NOAA, have issued a 45% probability of being above normal season, 35% for being a near normal season, and only 20% for below normal season. They're expecting 11 to 17 named storms, 5 to 9 hurricanes, and 2 to 4 major hurricanes. Major hurricanes are category 3 or greater, 111 miles per hour or stronger, sustained winds. So their main outlook is based on El Nino, which they're expecting to be very weak. During El Nino years, research has shown that it increases wind shear across the tropical Atlantic basin, which results in less hurricanes during those stronger El Nino years. But this year they're expecting a weaker El Nino, and that's why they've come up with this probability as of right now. All right, we'll keep tracking the tropics here at Spot On Weather. We hope you've enjoyed this lesson, and we certainly hope you have a great evening. Stick with Spot On Weather for your latest forecasting needs. Remember, if we're not spot on, we're not doing it right. Have a great evening.